Hello, how's it going? In today's video, I'm going to be making a billboard. Now, a billboard is basically a flat two-dimensional image which is drawn on a plane, which sort of always faces the camera. If we had a geometry shader, we could create a billboard pretty straightforward. Just draw a point and then the geometry shader intercepts that and explodes it out into a whole bunch of things. What I'm going to do is I'm going to just use a standard method. In other words, take a plane model and spin it around. It actually turns out today's video is about anything but billboards. There's a whole bunch of other things. Just to start with, I have refactored the code in between videos. So if we go to the shaders file here, I have abstracted the lighting code out into these individual functions here, and those considerably neaten up the main code. I was actually going to do this in the last video, but the last video is getting long enough already, so I sort of set it as an exercise. And yeah, you can jump through this and have a look at that, satisfy yourself that it looks good. And the other sort of refactor that I did in between is I simplified the draw code with external functions. So the tasks of sending data to the shaders for the uniforms and preparing everything, binding meshes and materials and all of that has been done in these functions down below. And again, I would encourage you in your own time just to check through those, check that they all make sense, but literally it's just copy pasting code. Okay, so on to the task of today. If we go over to the assets catalog, I've put in this, oh, no, we haven't done it yet. Okay, let's do it. So we'll just go to the project, textures, we've got this mouse. And we can sort of drag that into our assets catalog. And there we have it. It's been loaded, including the alpha channel. And let me just check. Have I got the mouse model? No, I haven't. Okay, so we can go over to the textures and, sorry, back to the models file. And then we have this mouse object. Can just, it's a pretty small file, so it might be easier just to view it in the actual source code. So we see that by the vertices, this is a plane aligned at x equals 0, pointing in the y-axis, and with a normal of x equals 1. So it's pointing along the positive x-axis. So if we imagine drawing our billboard at the origin, the camera is somewhere in the positive x, the billboard is looking at the camera by default. And then as the camera spins around, the billboard will spin to face the camera. But that's okay. What we can do for now is we can just grab these material and object files and drag them in to our models group, copy those over. Okay, now we've got them. So I won't use them just yet because right now I want to change something. At the moment, if we run this, the drag gesture, well, build failed, that's not a good sign. What's the problem? Huh? Unable to log in with account. Just give me 1 second, guys. Okay, so look, I've never had this issue before, but I just looked it up and it says apparently this is the place to go. So we go to project and then signing and capabilities. Let me just try sign in, see if that fixes it. Okay. How weird is that? So apparently there are ways to set up so it doesn't automatically manage it or some stuff. Anyway, that's weird. Let's run this again. Okay, now remember we're using a drag gesture, so if I click and drag, it sort of affects the camera's direction. Now I want to sort of invert this, so instead of the camera tilting, looking around, I want the camera's position to change relative to the origin. So I want the camera to sort of strafe around, that is to move according to its right and up vectors and maintain its target that it's looking at. So I'll sort of go through this the naive way. I had some issues implementing this, and I'll show you how we can fix it. So we'll go to the model and game scene. And up here we have a function called spin player. We're going to make another function called strafe player. Okay, now just to make things nice and smooth, I'm going to take the offset, and I found dividing it by 1,000 was a nice multiplier. Okay, and I'll just get rid of this for now. Then I'll go to the entity and I'll give it a strafe function. For now, let's just worry about the right amount. So we'll say, okay, position, we want to take our position plus the right amount times our right vector. Okay. Yeah, we need to just unwrap that. Okay, so we can now go back to the view, and I believe it was app view. Let's see that. Yeah, this is the one. So instead of connecting the spin player function, we'll connect the strafe player function. And we can just give this a shot. Oh, sorry, one other thing that I missed. So also, I want to set it up so we're always looking at the origin. So what we can do is, this is the update function. We'll just go, okay. For our forwards vector, if we take the position we're looking at, which is the origin, minus the position that we have, that can be our forwards vector, and nothing else has to change here. That's looking okay. Of course, we can always hard code the position that we're looking at. Okay, now let's give this a shot. Alrighty, so here we are looking at the camera. Oh, that's weird. Right amount was never used. What's wrong with you? I'm using it right here. What are you complaining about? Oh, in game scene. Okay, yeah, of course, because we haven't connected this up. Let's go player. See how that goes. Now when I click and I drag to the left, it spins around. When I click and I drag to the right, it spins around. But let me show you something. If I just sort of keep doing it repeatedly, the camera seems to get further away from the object, from the origin. And if I reverse it, so I go right, it doesn't change, doesn't fix it. So that's really frustrating. How do we fix that? Well, let's just finish this off. Just for future, times our up vector. Okay. And we can just run this again. And now if I click and drag down, or up, it moves. But we still got this issue where if I drag too much, it tends to, well, this isn't as obvious, but it is sort of gradually moving away from the object, which isn't good. See, if I go the other way, it still moves away from the object, so it doesn't reverse. Anyway, so what will we do in this sort of situation? Well, I do know another way to fix this problem, and that is sort of have a parameter, which is the angle that the camera is in the horizontal plane and the vertical plane, and just adjust that angle, and the position will always be like a start position plus a radius times various cosines and sines. That'll make sure that the camera doesn't drift too far away. But another good opportunity, this is a good opportunity to sort of have a look at printing out some debug info. So if I go over here to this app view, here we are. Let's get rid of this. Remember that the whole point of doing this stuff in SwiftUI is that we still have the SwiftUI suite of things. You know what I mean? So we can still make standard labels. Let's make a vertical stack. And why not? We'll put some text. Okay, just shot. What do we got? Yeah. Close off that stack. All right. So now, yeah, we're just adding text. So let's add some text labels with the camera data. Okay, so we can run this and yep, we've got the info, but there's a problem. And the problem is that when we move the camera around, that info is not updating. Why is that? Well, the view has an environment object, which is the game scene. And if we go to the game scene, it does conform to observable object. And it is publishing these variables. So when any of these variables change, the view will update. Issue is, we're not changing the reference to the player. We're not changing to a different player object. We are changing a property within the existing object, which just for whatever reason, it doesn't register as a change. So what we can do is make a function to sort of manually indicate that a change has occurred. Where is it? So we'll just make this here. We'll call func. Update view. We're going to send a message. We're going to go self. Object will change and send that message. Seems a little weird. This is not, okay, full disclosure, I didn't write SwiftUI. I don't think this is good English. Object will change. But hey, we just have to work with it. So after we update, that's where the player's position is changing. After that, we'll go update view. All right, and let's give this a go. So now we have the position, drag it, and yes, good, awesome. Position is changing. Okay, it's not a lot of helpful info because the issue that I'm having at the moment is why is it moving backwards when we spin according to the right vector? So I just want to verify that the forwards, right, and up vectors are sort of orthogonal to each other. So to do that, I'll just print all of those out. So we've got that's position. And then we'll go forwards, right, up. Okay, so we can run this. Haha, what's going on here? Ah, right, okay, so it says we found nil while unwrapping, and if we trace back through all of this, the forwards, right, and up vectors are really only set in this update function. So when we go here, add camera component, let's actually update directly after doing that. And similarly, why not? Let's update after adding a transform component. Okay, now the check is, are these three vectors orthogonal to each other? In other words, if I take the dot product of both, any pair of them, will it be 0? So if I compare forwards to right, we'll have in the Z component 0 times that, so that doesn't count. And then this will be some number about 0.42, and this will be about negative 0.42. So those will cancel out. And it seems to be the same if I check with the other vectors. They are in fact orthogonal to each other. I guess the issue is there might be slight rounding errors, so that although these are basically all orthogonal to each other, in reality, not quite. And that's what's causing the camera to move forwards and backwards a little bit. So the other thing to look at is the distance that the camera is from the origin. So we can go to the app view and let's add distance. And because we're measuring away from the origin, we can just take the magnitude of the position, and that's basically how far we are away from our target. So we'll go so we can see we start at a distance of 9.38 units from the origin, and then as we keep moving around, that distance increases for whatever reason. Rounding errors, math, who knows. But anyway, we can keep doing this, and it never really decreases. So this is a problem. So this gives me an idea for a quick fix. Is when we update the camera, let's check the distance and then move the camera to maintain a certain distance from the origin. So we can go back to the strafe. And I'm going to make a new function called move forwards. And that pretty much is what it is. So what we'll do is we'll get position plus the amount times our forwards vector. And now after strafing, we'll sort of measure how far we need to go forwards. So we'll get the distance from the origin. What do you mean cannot find amount in scope? It's right there. Jeez, okay. Okay, so then the question is, what do we want to do? Well, if our distance, okay, so let's say we want to get a distance of 10. I'll go with that. Fix a distance of 10. If our distance is 11, that's more than 10, so we want to move forwards by a positive amount. So we'll take the distance, subtract the target distance we want to be, and that is how far we'll move forwards. Let's give this a go. And now we can see up to some negligible, like at some point, we can kind of, yeah, at some point it might be a little bit, it's fine. It's fine. The distance is constrained, and barring a few graphical glitches, this is looking pretty okay. It's stable. This has given me some confidence. Okay, so I'm happy with that. The next issue is we want to actually make a billboard and draw it. I'm going to use the same sort of setup that I've been using, like the same pipeline. Possibly look at multiple pipelines at a future point. So let's go to the renderer and load in the assets that we're going to need. Actually, yeah, why not? Let's do this first. Okay, so going to separate this. So I'll have a mouse mesh. And a mouse material. And I just realized I don't like calling this an allocator. I'm going to call this object a mesh allocator. So we have mesh allocators and material allocators. Yeah, that's fine. Okay, so we'll load our mesh and material. I believe that was mouse. And for this one, we can always check, go to our assets catalog. It's a mouse. Okay. So we want it to be funny there. That's a nice one. Okay. Mouse. Right. Now let's go and create a billboard object. So we'll go, now we could add this as a component within the entity class. I'm quickly realizing that making an entity class was sort of a really lame idea, and I'm going to make a billboard class. So we'll just go, where are we? New file. We'll call this billboard. Okay. Okay, so we'll just create this. We'll be given a position and we'll store that in our variable. And we're going to have a model matrix. That's a horrible idea. That'll be a matrix. That's matrix float for, oh, geez, come on. There we go, matrix float 44. All right, so go to our matrix library and just create the identity matrix. That's fine. Okay, there's our constructor. What we'll have is we'll have an update function. The update function will take, let's take nothing right now and just draw it as it is. So we'll go, actually, let's take this in, but ignore it right now. So we'll take viewer position, be a vector 3, but we won't use it at the moment. We'll just go model. There we go. I'll update this in a second. All right, so this will pretty much just draw it with no rotation, just where it is in place. Now we can go to our scene and create one of these. So we'll have, where are we? Okay, so I want to sort of position this mouse at the origin, but I want to move it up a bit. So I think the cube, I believe, had a height of 2, and the mouse has something on top of that. So let's set the mouse at a height of 2.7. There, we got it. Okay, cool. So when we go to update, we'll go mouse, update. Okay, and then we'll go to draw it. So we'll go to the renderer, and then in the draw function, where are we? Okay, so very straightforward. What we'll do is we'll arm the thing for drawing. So pass in our render encoder. Going to arm the mouse mesh and the mouse material, and then draw that. Uh-oh. What's going on? I may have passed in the incorrect file name. Let's check this again. So we go models. Huh. Mouse.obj wasn't added. Why is that? I love when things don't work. Okay. Wrong one. This is what this video is basically. This video is just me complaining about things not working. Okay. There we are. Good. Give that a shot. Okay, perfect. So we have it here. Of course, there's an issue, isn't there? We want the we sort of want the texture to be transparent. So then the question is, how do we add transparency to textures? And actually, this is a good point for me to bring up the Apple documentation. So if we just search Apple Metal Alpha Blending or whatever, then we have this developer.apple.com section, and it has some pretty cool info here. So looking in here, I can see this is sort of tied to the Metal Render Pipeline Color Attachment Descriptor. Okay, so we have all of these things, super important. So what do we have here? We have is blending enabled? That's a Boolean. Blend operation, RGB blend operation. Okay, so let me just sort of do this in the naive way, which is we go back up here, and here's our color attachment. So that's what I want to change. So go is blending enabled, set that to true. Okay, so alpha blend operation, I want that to be, we look at all of these, it's add, basically. And I know what you might be thinking, hey, if we add, won't that be lightening the color? Well, of course, that's where we use factors. So then we have destination alpha blend factor. We have a whole bunch of these. Now we have a source and a destination. The source is the pixel which is being written, and the destination is that location where it's being written to. So let me go through the 10% alpha. So I have something that I'm drawing on something with 10% alpha. I want the final color to be 90% of the existing color plus 10% of the incoming color. So the blend factor for the destination will be 1 minus the source alpha. And then the source alpha blend factor will be the source alpha. Okay, so here's the thing. This looks okay. This makes sense, right? This is more or less how we do it in OpenGL. Let's run this. And the problem is, it is not doing anything. Now, before we lose faith in ourselves or check that our texture is, working properly or whatever, let's just do a little experiment. Let's go back to the shader. And look at what we're doing here. Oh, we're writing in a value of 1. Well, of course, we're not going to display anything. So there are a bunch of different ways to do this. Let's go float alpha equals, and then we'll just do the same sampling operation again. But just get the alpha component. And let's try this. Okay. Nothing. Okay, so again, before we lose faith, let's just hard code in a value for alpha and check that it works. So 0.5. Okay, so this, everything should be partially transparent except the background. And that's not happening either. So this brings us to what's actually happening here. And that is, there is a difference between alpha blending and RGB blending. Those two things are sort of done separately. So what we can do is we can go to the renderer and we say, okay, we've got the alpha blend operation. Oh, whoops. I also want to set the RGB blend operation. Okay. And I'm going to set the blend factors for those as well. Okay, so as you can see, the color components, so red, green, blue, are being blended according to the alpha. Hopefully that makes sense. All right. So run that. And yes, good, awesome. So we can hard code in an alpha value and it is working properly. We can go back and now use the sampled alpha value. So we can go, and instead of 0.5, we can put alpha, and fingers crossed, and it's working. It's a little bit messed up, but that's more to do with my Photoshop skills or lack thereof. So that's looking good. The final step, it's actually fairly simple, is just to make this behave like an actual billboard. So to make it spin around to face the player. So imagine that we are looking at the player. By default, we're looking down the positive x-axis and the camera is somewhere on the positive x-axis. We're looking at the player. No rotation needs to happen. Now imagine the player spins around the spins around at an angle from the x-axis. Well, the billboard would spin at that angle to face the player. So, long story short, we need to get a direction vector to the player. So here we have, okay, let's go. The direction vector to the viewer. Okay, good. And then we want to get the angle in the XY plane. So this is done with ATAN2. So ATAN is arctan, and ATAN2 is a version of arctan which is in the correct quadrant. This is sort of a standard thing in almost all math libraries, going back to GameMaker when I was first programming. They all have an arctan2 and it's all sort of quadrant correct. So the first argument is the Y component, which is go self to viewer, component 1. And the second one is the X component. And I don't know why Did I write that wrong? I don't know why it goes YX instead of XY. Who knows? It must be convenient for someone, but anyway. So we have this, and now let's replace this part here. So we'll go create from rotation, and then for the Oilers we'll have 0 degrees around the X-axis, 0 degrees around the Y-axis, and the angle around the Z-axis is theta. Okay, but we have an issue. It's not changing. And the reason for that is that by default, this function returns things in radians, but we want to sort of, for our math library, convert it to degrees. So we multiply by 180 over pi, and that converts it to degrees. Fingers crossed. And now, okay, so you may not have noticed before, I didn't mention it, but the lighting was a little bit messed up. Now the lighting is consistent, and as the player moves around, the image is always facing them. Then we just need to do the vertical angle, because if I angle myself up, it now looks like a piece of paper again. So what we'll do is we'll basically do the same thing. So we'll say, first of all, get the horizontal distance, the distance in the XY plane. Okay, and where was I? Now we can get the vertical angle phi by the same trick. Okay, so the vertical separation. If we imagine looking at something in the flat plane, then the sort of the y difference there will be the actually the z difference, and the x will actually be the flat distance along the horizontal plane. Then we'll do the same thing, so we'll convert that to degrees. And we can pass that in as our angle around the y-axis. Okay. All right, so that looks fine. Now as we angle ourselves, sort of doing the opposite. It's actually easy enough to fix. We can just apply the reverse. There we go. Now we can angle ourselves around, and as we go up, yep, it's always facing the camera and always facing the camera. It's a little bit nasty there, but hopefully you can see why that's happening. Some planes are right up against each other. Okay, so there we have it. That is an example of playing around with shaders and making billboards. Hope you enjoyed that. Hope that helped, and I will see you again soon. Bye.